We're going to start with Newton's three laws. Newton's first law of motion, often called the law of inertia, states that an object continues in a state of rest or uniform motion in a straight line unless acted upon by an unbalanced force. Newton's second law states that an unbalanced force causes an object to accelerate. He came up with the equation F equals ma, where F is the force in newtons, A is the acceleration in meters per second squared, and m is the mass in kilograms. Newton's third law of motion says that for every action force, there is an equal and opposite reaction force. Next, we are going to talk about mass and weight. Mass may be defined as either the amount of matter in an object or the measure of inertia possessed by the object. Weight may be defined as the force due to gravity acting on an object. For weight, the equation is written as Fg equals mg, where Fg is weight, m is mass, and g is the acceleration due to gravity. Net forces. A net force can be calculated by adding all the forces acting upon one object. Direction must be accounted for. When two forces oppose each other, the net force may be found by subtracting the smaller force from the larger force. Free body diagrams communicate the types of forces acting on an object, the direction of the forces, and the relative magnitudes of the forces. Here's an example. A box is sitting on a table. First, we draw a circle to represent the box. Then, we draw all the forces acting on it. Net force equations. Let's use the box sitting on the table again. First, you want to draw your free body diagram. Then, you create a net force equation. You always write F net equals ma. Then, if the object is at rest or at a constant velocity, you write it equals 0 because the acceleration is also 0. Then, you write all the forces acting upon the object with their direction. Let's say this car is accelerating to the right. First, we draw our free body diagram. Then, since there are forces acting in the y-plane and the x-plane, we have to create two F-net equations, one for x and one for y. Forces. Fg, we already know, is the force due to gravity. Fa is the force applied. It is a force applied or exerted by a person, animal, machine, or colliding object. Fn is a normal force, which we also already saw, a force of support exerted on an object by a table or some other surface. It is always perpendicular to the surface. Tension. A force that is applied using a string, rope, or cable. It pulls equally on the objects on each end. Spring force, the force exerted by a compressed or stretched spring on any object that is attached to it. For spring force, the equation is Fs equals negative Kx, where Fs is a spring force, K is a spring constant, and X is a displacement. Frictional force, the force resisting motion of two objects sliding against each other. The equation for frictional force is Fr equals mu Fn, where Fr is the frictional force, mu is the coefficient of friction, and Fn is the normal force. Friction is parallel to the surface and opposes motion. Now we will talk about static and kinetic friction. Here we have a graph. On the y-axis there is the force due to the friction. On the x-axis there is the applied force. The force due to friction keeps increasing until it reaches mu s, which is the coefficient of static friction. Once it reaches that, it drops down a bit to mu k. That is the threshold of motion. Once it reaches the threshold of motion, mu k is constant. The coefficient of kinetic friction is always smaller than the coefficient of static friction.